Is DJ coming today? That's all coming.
Yeah, I have to go do what it is we calculate the theoretical view. Well, compared to theoretical view. Well, this is the flow. This is the actual. So this is theoretical.
Whoa. Dude.
Yeah, you have to use the flow to calculate.
Is there an oscillation problem?
No, it's okay.
Is this a simpler oscillation problem? Ventilation? Concentration?
Yeah, and I've been busy. I apologize. I'm going to be here all night. No, I just have to get it all lined out. Yeah, well, once I have it connect to each other, it's all good. We'll figure it out. Are you not fucking around? Do you have pictures?
Yeah.
Do you not believe? Will you get that full notebook for me? I'll just drop it in there.
Where's Dana? I feel like you drove the same one every time, and I never understood. You have to visualize it. Imagine it as a cookie. You have XP cookie, that's your that's your base. I can't do it right now. ZZ is the cookie itself. That's how it crumbles. YD is the frosting. Alright, Gateway. I'll lay you off the hook. So you tell me this. So you have this cake, right? You cut it in half. And then you take the other half and then you cut one. You keep cutting it. So look. Here's the cake. You cut this in half. You leave this part alone. And you cut this part in half. And you leave that alone. And you keep cutting it. If you stack it on top of each other, what's the volume? Oh, wait, what can you do? Can you eat it or can you frost it?
You know what?
Or put frosting on top of it? You can't do one.
So here's what we're doing. We have the simplest distillation problem imaginable. C equals 2.
Frosting? No, that's the
We're
top
given the
layer,
feed, the
'cause
feed
it's
composition, and the feed enthalpy. We're given the pressure. We're given the equilibrium curve. We're given 2 product specifications. See the overhead purity and the overhead recovery. First thing we can do is make material balances, get dB and XB. We're also given the reflux ratio, and our job is to, and we're going to assume equilibrium stages. We're going to assume equal mole overflow. Our job is to find n, the number of stages, and say V prime. the boil-up rate. So V prime comes out of the reboiler while I'm putting heat in. L prime goes to the reboiler like so. And what we know so far is that we have a material balance line in the top of the column. And the material balance line on the top of the column is Y equals R over R plus 1. X plus must be 1 over R plus 1 Y. Let me see if I like that. X is equal to YD, R, Y is equal to YD. Yeah, I like that. Now, this R of R plus 1, of course, is L over V. So we have a line here of slope R of R plus 1, which is also L over V. And we're in the process of trying to put the material balance line in the bottom section. And the material balance line in the bottom section looks like Y equals, I guess, L prime over V prime. X plus must be 1 minus L prime over V prime XB. When X is equal to XB, when X is equal to XB, this cancels that. And Y is equal to XB, that's good.
Dr. Jones? So
it runs through here, but we don't quite know how to put it in yet because we haven't calculated L prime over V prime. Yeah?
What, can you just explain briefly what you're showing us?
Beg your pardon?
Like what are you deriving?
I'm doing what it is over here. I'm trying to do my job. My job is to find the number of stages and the boil-up rate, and I'm proceeding with the standard sort of a calculation to do that. So I have an equilibrium curve here. I have a material balance curve here in the top. And I'm working on putting the material balance curve in the bottom. And last time we pretty much had that, so let us continue with where we were.
Dr. Jones?
Yeah.
R refers to what? Is that the recovery rate?
Pardon?
What is R referring to?
What is R referring to? R is referring to L over D, which is called the reflux ratio. And it's a stand-in for the amount of heat that I've got to remove here. It'll become, that's a control variable that you would rather use rather than use QB as a control variable. It'll turn out when we make an honest heat balance, they're the same, but for now, I'm just going to control the column with the reflux ratio, which you can think of as QD if you want. They're related, 1 to 1.
Dr. Jones?
Oh.
At steady state, does V have to equal D?
Pardon?
At steady state, does V have to equal D?
Tell me where you're looking. Where up here are you pointing?
So on the column, you have D as the rate of the vapor.
Here's a vapor flow upward. Here's a vapor flow upward.
Okay, so V is dependent on position.
Well, we've assumed equimole overflow, which is going to give us a constant V above the feed and a constant L above the feed. But when you put the feed in, these flows will change, so we're calling them L prime and V prime. We're working on finding out how, let's see, have we got everything up here we want? If we knew L prime over V prime, we could draw this line here, but we're not going to quite do it that way. We're going to more or less do it that way. So I've got everything here that's on this picture the way it ought to be. That picture translates into this picture the way it ought to be. And we'll just keep in mind that this is what we're trying to do.
Like a line?
Now, the last time we said something like this, we went to the feed plate. We don't know where the feed plate is. we're going to choose the feed plate ourselves to help us. So we go to the feed plate and we wrote a couple of balances, one of which was something like V minus V prime minus L minus L prime. We also wrote the heat balance around there in an approximate way. And we learned something like L minus L prime equals V minus V prime times something or other. I guess it was something like H minus HF over H minus HF, which I suppose if we had any sense we would have done this. I don't recall. H minus H minus HF minus H over H minus HF. We'll just call this lambda. And so this group here became lambda, I see it there, H minus HF, I see it there. Switch this, make that a plus, plus 1. So I guess we probably wrote that. And we said to ourselves, well, you know, assuming we know something about assuming we have some data, and assuming our assumptions are more or less reasonable, and they are in many cases, we have L minus L prime in terms of V minus V prime, and we could stick that back up in there, and I will do that at some point. So I'm going to take this and put it up in there and use that at some point. But I don't have to do that right this minute. So let me do one thing first, and I actually think we did this last time too, but I'm not sure. I think we said, I wonder where these lines intersect. This is the material balance line in the top. And this equation is this line here. And this is the material balance line in the bottom, which I haven't put in yet. So I'm going to subtract these and write y times v minus v prime equals x times L minus L prime plus z f. And I can always write f as v minus v prime minus L prime if I wish. Now, this is clearly a line which, when x is equal to z, you see y is equal to z. So this is what we are going to call our feed line. Our feed line, and it is not a, it's a helping line. But it's clear that it goes through the point ZZ here. And it's also clear that it has slope. Slope of that line is slope.
Professor Johns?
I'll get with you. L minus L prime over V minus V prime. And I happen to have L minus L prime over V minus V prime. L minus L prime over V minus V prime is this stuff here, lambda over H minus HF plus 1.
Something entering and leaving.
I know that slope, so I can draw this line. So I draw this line through here. This is my helping line. What's up?
In the second parentheses on the second to bottom line, it says plus z times something.
Yeah.
Here?
Yeah, where it says
to the
Z
right.
times.
Y times V minus
The Z,
V
the
prime,
Z.
X times L minus L prime, YDD plus XBB is ZF, here's the Z,
Yeah.
and this is F.
That's just f.
Yeah, that's F, isn't it? Here's F right here,
Okay.
Oh, okay, I
now-
see it now.
okay? So I draw this line. Now, this line depends upon the condition of the feed. It's a line that goes through the feed point on there. Depends upon what enthalpy the feed has and so on and so forth. And we probably ought to take a few cases, but the point is that once I have this line on here, and I know this point here, I simply draw this line through here in full confidence that it's got the right slope. Okay, so I have a construction line that helps me draw the line in the bottom of the column. So this is the material balance line below the feed. And I got a material balance line above the feed and a material balance line below the feed, and I'm about ready to roll. But I wanted to say a few things. We're about ready to make a calculation. And let me look and see if I like this graph. Yeah, this is an okay graph. I probably want to leave that there. So let us check a few cases out and see how we would draw that line for various kinds of feed. Okay, so I'm interested in L minus L prime over B minus B prime, which turns out to be this. So it's the slope is equal to lambda over H minus HF plus 1. So, case 1. We've already talked about case 1. HF equals H. There must be a sign wrong somewhere. No, there's not a sign wrong. It looks like the sign's right. If H minus HF, if HF is equal to the sum, this is called saturated liquid feed. Saturated liquid feed. The slope of the line's infinite. So the saturated, so we'll put down a few cases over here. So if we have saturated liquid feed, the slope of the line looks as follows. Here's a few feed lines. A few feed lines. The feed is here. Saturated liquid feed tells me that line is straight up, or, well, it's a vertical line. Okay, that's a typical case people might like to talk about. Case 2 would be maybe it's saturated vapor feed, in which case HF equals H. This is saturated vapor feed. And I look at this, HF equals F. This is minus 1 plus 1. Slope is 0. So for saturated liquid feed, it's like that. For saturated vapor feed, it's like that. Now, there's many other cases. I'll deal with one more. Let the rest of them for you to enjoy. A typical case is where the feed is cold. So the feed is cold. That means that HF equals H minus a certain amount of subcooling. Delta T will be the subcooling, so it's CP delta T. So H minus HF is CP delta T, and so for case 3, which is cold feed, case 3, cold feed, I'm gonna say, what is my formula? It's H minus HF, so it's lambda. It's lambda over, something about that I don't like. Yes, something about it I actually like. CP delta T